Welcome back to our deep dive into the fascinating history of the Lucasian Professors of Mathematics at Cambridge.
Yes.
In our previous episodes, we explored the lives and contributions of the first 5 individuals who held this prestigious position, from Isaac Newton
Oh, wow.
to Isaac Barrow. Today, we turn our attention to the 6th Lucasian Professor, a figure often shrouded in mystery,
Interesting.
Edward Waring.
Waring is an intriguing character.
Yeah.
His work, particularly in number theory, continues to resonate centuries later, but his dense writing style and perhaps his personality made him an enigma even to his contemporaries.
All right.
To truly understand Waring's contributions, we need to delve into both his life and the unique mathematical landscape of 18th century Britain.
Okay, let's start with his background.
Okay.
I find it fascinating that Waring wasn't born into an academic family.
Mm.
Our sources indicate he was the son of a farmer,
Oh, wow.
born in Old Heath near Shrewsbury, sometime around 1736. How did a farmer's son rise to become one of the leading mathematicians of his time?
That's one of the questions that makes Waring so compelling.
Yeah,
Despite his humble beginnings,
right.
he displayed an exceptional aptitude for mathematics from a young age.
Uh-huh.
After his early education at Shrewsbury School,
Okay.
he entered Magdalen College, Cambridge as a Caesar.
The Caesar.
That meant he received financial assistance in exchange for performing various duties.
Interesting.
This system, common at the time, allowed talented students from less privileged backgrounds to access a Cambridge education.
And Waring clearly thrived in this environment.
But Ed,
He achieved the highest honor for a mathematics graduate at the time, becoming Senior Wrangler in 1757.
Senior Wrangler,
For our listeners who may not be familiar with this term,
right?
Senior Wrangler was a top scorer in the grueling Cambridge Mathematical Tripos exam, a multi-day examination that tested students on a wide range of mathematical subjects.
It was quite the challenge.
Wow.
Becoming Senior Wrangler was no small feat. It signified exceptional mathematical ability and was a stepping stone to an academic career.
Oh, I see.
Waring's achievement demonstrates his early brilliance and set the stage for his rapid ascent in the mathematical world.
It's clear that Waring quickly made a name for himself at Cambridge.
Yes, he did.
He became part of the Hyson Club, a social club for intellectuals at the university.
I see.
I imagine this provided him with valuable connections and intellectual stimulation.
Absolutely.
Yeah.
The Hyson Club was a hub for some of the brightest minds at Cambridge.
Oh, wow.
It was here that Waring rubbed shoulders with figures like William Paley, a prominent theologian and philosopher.
Interesting.
These connections undoubtedly played a role in shaping Waring's intellectual development
Right.
and opened doors for him within the university.
And just 4 years after earning his Bachelor of Arts degree at the incredibly young age of 24, Waring was appointed Lucasian Professor of Mathematics in 1760.
That's impressive.
That's astonishingly young for such a prestigious position, even by today's standards.
It was a controversial appointment, to say the least.
What?
Waring's youth, and the fact that he didn't yet possess the required Master of Arts degree raised eyebrows.
I see.
There was opposition from within the university, particularly from William Samuel Powell, a tutor at St. John's College.
What arguments did Powell use against Waring's appointment?
Well,
Was it purely based on his age and lack of a master's degree, or were there other factors at play?
Powell's objections seem to have stemmed from a combination of factors.
Okay.
While Waring's youth and lack of a formal MA degree were certainly points of contention,
Right.
it's also likely that Powell,
Yeah.
like many in the British mathematical establishment at the time, might have been wary of Waring's analytical approach to mathematics, which differed from the prevailing geometrical focus favored in Britain.
That's interesting.
Yeah.
It sounds like there might have been a clash of mathematical philosophies at play here as well.
It seems so.
But Waring also had his supporters, right?
He did.
What were their arguments in favor of his appointment?
Yes, Waring had influential supporters like John Wilson, a fellow mathematician who would later become the 9th Lucasian Professor himself.
Oh, wow.
They likely recognized Waring's extraordinary mathematical talent and saw the potential in his innovative analytical approach.
So they were forward-thinking.
Yes.
Okay.
Ultimately, despite the opposition, Waring's supporters prevailed. However, because he didn't yet have his master's degree, a royal mandate from King George II was needed to secure his appointment.
A royal mandate.
Imagine that.
That's a testament to both the prestige of the Lucasian Professorship and the recognition of Waring's exceptional talent despite his young age.
Indeed.
Wow.
Waring's appointment, though controversial, marked the beginning of a prolific and influential, if sometimes misunderstood, career in mathematics.
So let's talk about that career.
Okay.
Now that we've set the stage with his rather remarkable rise to the Lucasian Professorship, what were some of Waring's key contributions to mathematics during his tenure?
Well. Waring made significant contributions across various areas of mathematics, publishing several important works during his time as Lucasian Professor.
Okay.
One of his most notable publications was Miscellanea Analytica,
Miscellanea Analytica.
published in 1762,
Oh, wow.
just 2 years into his professorship.
This book seems to have played a crucial role in establishing Waring's reputation as a mathematician.
Yes, it did.
What were the key areas of focus in Miscellanea Analytica?
Miscellanea Analytica focused primarily on number theory and algebraic equations, areas where Waring would make some of his most lasting contributions.
I see.
The book contained a wealth of new theorems, but it was also notable for its challenging style, even for seasoned mathematicians.
Our research notes mention that Waring's writing was often dense and difficult to follow.
Yes.
Did this hinder the reception of his work?
It's likely that Waring's writing style did limit the immediate impact of his ideas.
Right.
He often omitted steps in his proofs and jumped between ideas, assuming a level of mathematical sophistication that many of his contemporaries may not have possessed.
It's almost ironic that someone who achieved the highest honor in the Cambridge Mathematical Tripos, an exam known for its rigor and detail, would then go on to publish works that were considered obscure and difficult to follow.
It is a fascinating contradiction.
Yeah.
Perhaps Waring, with his exceptional mathematical ability, simply saw connections that others didn't, making it difficult for him to articulate his reasoning in a way that was accessible to a wider audience.
It sounds like he was thinking on another level.
Yes, quite possibly.
Despite these challenges, Miscellanea Analytica did garner some recognition, didn't it?
It did.
Okay.
The book, especially its later revised edition, published in 1785, was well received by some prominent mathematicians on the continent.
Like who?
For example, the renowned French mathematician Jean-Léron d'Alembert praised Waring's work.
D'Alembert.
Yes.
That recognition must have been encouraging, especially given Waring's admiration for continental mathematicians.
Absolutely.
Yeah.
Waring felt that mathematics was more rigorously pursued on the continent, particularly in France and Germany, than it was in Britain.
He was a critic of his own system then.
In a way, he drew inspiration from the work of mathematicians like Euler, d'Alembert, and Lagrange, and advocated for the adoption of their analytical approaches in Britain.
So, in a way, Waring was a bridge between these two different mathematical cultures.
I think that's a great way to put it.
Yeah.
He was exposed to the latest advancements in continental mathematics, and tried to bring those ideas to the attention of his British colleagues, even if his efforts were sometimes met with resistance.
Because they were so entrenched in their own views.
Perhaps.
Thanks.
He challenged the prevailing geometrical focus of British mathematics, even going so far as to subscribe to John Landon's residual analysis.
What was that?
A work that questioned the very foundations of Newtonian calculus.
Oh, wow. So he was really going against the grain.
It seems so.
It seems that Waring wasn't afraid to ruffle some feathers in the mathematical community.
He was an independent thinker.
Yeah.
For sure.
But let's move on to another one of his significant publications, Meditationes Algebraicae.
Okay.
What can you tell us about this work?
Meditationes Algebraicae, published in 1770, is perhaps Waring's most significant work.
Really?
It was a major contribution to number theory and algebraic equations.
Okay.
And contains some of his most profound and enduring conjectures.
Interesting.
Even Lagrange, whom Waring greatly admired, praised it as a work full of excellent researches.
High praise indeed coming from Lagrange.
Yes, quite high praise.
Waring's work on algebraic equations,
yes,
as complex as it was, is a topic for another deep dive.
Agreed.
What really captured my attention during our research was a particular conjecture contained within Meditationes Algebraicae that would become known as Waring's problem.
Okay.
This problem has fascinated mathematicians for centuries.
It has.
And is still the subject of ongoing research today. Could you explain the essence of Waring's problem to our listeners?
I'd be glad to. Let's start with something familiar. Squares.
Okay.
We know that some numbers can be expressed as the sum of two squares.
Yeah.
For example, 13 can be written as 2 plus 3 benimal.
2 plus 3 eminal. Okay.
Other numbers might require 3 squares or 4.
So not all numbers can be expressed as the sum of 2 squares.
That's right.
And this is where Lagrange's four-square theorem comes in.
Right, exactly.
It states that every natural number can be expressed as the sum of, at most, 4 squares, right?
Precisely.
Now, wherever The curious and probing mind took this idea a step further.
He did.
He wondered if every number can be expressed as the sum of at most 4 squares. What about cubes?
Interesting question.
Or fourth powers?
Or higher powers.
Or higher powers?
Yes.
Can every natural number be expressed as the sum of a limited number of cubes, fourth powers, and so on?
That's the question at the heart of Waring's problem.
This is the essence of Waring's problem. So he was essentially generalizing the idea behind Lagrange's four-square theorem to higher powers.
Exactly.
That's incredibly ambitious.
It is.
But how do you even begin to tackle such a problem? I imagine it gets quite complex very quickly.
It does get complex, but that's where Waring's genius shines through.
Okay.
He introduced two key concepts to formalize his problem.
Okay.
GK and GK. These might sound intimidating,
Yeah.
but they're actually quite intuitive once you understand what they represent.
Okay, let's break them down.
All right, GK represents the minimum number of Gaith powers needed to express all natural numbers.
All natural numbers.
Yes, so for example, G2,
G2.
relating to squares equals 4.
Okay.
Because Lagrange's four-square theorem tells us we need at most 4 squares to represent any natural number.
Okay, so G2 is 4.
That's right.
What about cubes?
Ah, yes, cubes.
If Waring's problem holds true, there should be some number of cubes that can represent any natural number.
That's right. It turns out G3.
9.
This means any natural number can be expressed as the sum of at most 9 cubes. For instance, the number 23 can be written as 2n1 plus 2n1 plus 1n1 plus 1n1 plus 1n1 plus 1n1 plus 1n1 plus 1n1 plus 1n1.
Okay, so a lot of 1-n's.
It takes 9 cubes in this case.
9 cubes, so that's how GK works. But what about GK?
Right. GK is similar, but it focuses on representing almost all natural numbers.
Almost all.
Yes, it allows for a few small exceptions.
I see.
Essentially, GK is the minimum number of nath powers needed to represent all sufficiently large natural numbers.
Okay, so GK is about representing every single natural number without exception.
Correct.
While GK focuses on representing the vast majority of numbers, with a few small numbers potentially requiring more terms.
Precisely.
And determining the exact values of both GK and GK for different powers is incredibly difficult.
Incredibly difficult.
And this is where Waring's problem has captivated mathematicians for centuries.
Yes.
Finding those values has been an ongoing challenge, hasn't it?
It has. While some values of GK and GK have been solved, others remain open problems to this day. Mathematicians have made significant progress over the years, but Waring's seemingly simple question has led to incredibly complex and fascinating areas of number theory.
It's amazing to think that a question posed by a mathematician in the 18th century continues to drive mathematical research in the 21st century.
It is truly remarkable.
It speaks to the depth and enduring power of Waring's insights.
Absolutely.
Before we wrap up, I want to touch on something that struck me while researching for this episode.
Okay.
Waring, despite his brilliance and contributions, remained somewhat of an outsider in the mathematical community. He admired continental mathematicians, but was critical of his British contemporaries.
Yes.
His writing style made his work inaccessible to many.
That's true.
Even his personality,
Yes.
from what we can gather, was characterized by shyness and a tendency towards melancholy. How do you reconcile these contradictions with his undeniable genius?
I think it's important to remember that brilliance often comes with its own set of challenges.
Yeah.
Waring's story reminds us that intellectual giants are still human with all the complexities and quirks that come with being human.
Right.
His struggles with communication and his outsider status may have limited his impact during his lifetime, but his work ultimately transcended those limitations.
It's a reminder that groundbreaking ideas don't always come neatly packaged and easily digestible.
That's a great point.
Sometimes it takes time and effort to decipher the insights of truly original thinkers.
And those who put in the effort are often richly rewarded.
Yeah.
Waring's work, once deciphered, has opened up new avenues of exploration in number theory, influencing generations of mathematicians and leading to the development of powerful new mathematical tools and techniques.
So as we conclude our exploration of Edward Waring, the 6th Lucasian Professor of Mathematics, we're left with a sense of awe at his intellectual legacy, but also with a deeper understanding of the complex and often challenging nature of mathematical progress.
It's been a fascinating journey into the life and work of a truly enigmatic figure.
Waring's story reminds us that the pursuit of knowledge is rarely straightforward. It's a process filled with twists and turns, triumphs and setbacks, but Ultimately, it's the big questions,
Yes.
the ones that challenge our assumptions and push the boundaries of our understanding that drive us forward.
And who knows, perhaps one of our listeners will be inspired by Waring's example to ask their own big questions and contribute to the ongoing quest to unravel the mysteries of mathematics.
We encourage you to keep exploring, keep questioning, and keep diving deep. The world of numbers is full of wonders waiting to be discovered. Thank you for joining us on this deep dive into the fascinating history of the Lucasian Professors of Mathematics.
It's been a pleasure.
We'll be back soon with another episode exploring the life and work of another mathematical giant.